the RQ and parameterizing the RQ. Johannes, back to you. Let's go and see what we can do.
Okay, thank you again. Here, I will give you here a brief introduction about the main settings you should set in your RQ instrument using the Q Commander software. So these are the most important settings you have to consider to make your system running in the way it should for your selected measurement site. So here is a list of these basic settings you need to adjust, and we go through one by one. So you need to set the measurement trigger. How is your measurement started? You have these selections here. You can select an interval with this option. The RQ instrument has its own measurement interval. For example, here the interval is 20 seconds, so the RQ takes a measurement every 20 seconds by itself. And if you have connected a data acquisition system or a controller, you can use either a trigger signal or an SDI or RS-485 signal. And if you set the measurement trigger to trig input, then if the RQ instrument receives a current input, a physical current input, then it starts the measurement. And you can have a serial input by SDI 12 or RS-485. So if you have connected a data logger, you can send a signal to the RQ instrument to trigger a measurement whenever one is required. Then the next thing is the measurement interval. How much, how often do you want to measure? And you can select a measurement or a measurement interval between 20 seconds and up to 5 hours. And usually we use a measurement interval between 1 minute and 15 minutes, depending on your river and how fast the flow changes. And of course, the application you require the instrument for. Then you might need to set the water level limits in your sensor. We have 4 parameters in the setup with these acronyms here. So you have the WRQ, that is the mounting height of the RQ instrument. How this is set, I will tell you in a minute. Then you have the WMA, which is the maximum water level you expect in your measurements. So you might have some historical recordings that give you that information, how high the water level rises in your canal. And then there are 2 settings called WLL, which is the so-called low level border, and WCF, the seas of flow level. And the thing is that between these 2 levels, the flow velocity is so low that the sensor can't detect it anymore. So the velocity is extrapolated from WLL to the seas of flow level. But this usually is in the realm of about a few centimeters or decimeters, depending on the roughness of your river. And usually these 2 settings are kept at 0, and they actually most often don't need to be adapted. What needs to be adapted is the maximum water level and the installation height of the sensor. So here is a screenshot of a part of the setup of the Q Commander for the water level. And you can see here those 4 levels which are configured. The low level border and the seas of flow level are set to 0. The maximum water level in this case 8 meters. And the fixation level of the sensor is set automatically. As soon as you use this function here, adjust the water level. With this function, you tell the instrument what is my current water level I'm measuring, and if you enter this, the Q command software will automatically change this setting here to the water level we're measuring right now. So here's an illustration of what is done. Depending on the zero level you have defined when you build the cross-section profile. This zero level can be at the bottom of the river, or it can be the sea level, or any level in between. And so when you press this function here, adjustment, you have to tell the system what is my water level from the zero level to the water surface in whatever coordinate system you're using. Okay, then we have to set some parameters for the water flow. We have to tell the system the viewing direction. So we have to say to tell it, is my measurement looking upstream or is it downstream? When you're standing on the bridge, are you looking against the water flow or are you looking downstream with the water flow? Then you need to specify what are the flow directions. So usually the river just flows downstream towards the ocean, and so you just say just downstream. But if your measurement site is close to the ocean, you might get tidal influence, and then the water flow can go in both sides, downstream and upstream. And then you have to tell the instrument, okay, my flow can be in both directions, and I entered it or I select the tide option here. And then another setting is the measurement duration. When the flow velocity is measured, that instrument integrates the signals reflected from the surface for about 20 to 30 seconds. This is also the default, the standard values for the measurement duration. You can increase this measurement duration up to 60 or more seconds if you have very slow moving rivers, so that you get a better quality of your flow velocity data. This is also shown here in the setup of the velocity section of the setup. So the viewing direction, in this example upstream, the possible flow direction downstream, and the measurement duration, in this case 20 seconds. And then of course you need to specify the discharge table. We have heard that in our previous webinar, how to build a cross-sectional profile and how to generate the discharge table. When setting up the instrument, make sure that you upload the discharge table to the sensor, and so that it's available for the correct measurements of your RQ system. And then another important point is the units and the decimals. In the Q Commander setup, you have a section called unit and decimal, and here you can specify the units that are used to calculate the discharge. So you have the unit of the water level, which is usually meters. You have the flow velocity, which generally is meters per second, the discharge in cubic meters per second, and the total discharge, an absolute number in cubic meters. What you have to consider here most is the scale of your data that you're going to record. So you should avoid very small and very large numbers. So for example, if you have a square cross-sectional area of 0.013 square meters, you shouldn't use the square meter unit, but instead use the square decimal units. Because the instrument can only handle a certain number of decimal points, the result will be much more accurate if you select the 1.3 square decimeters instead of the 0.013 square meters. The same also for very large numbers, and especially we're looking here at the total discharge volume. If you have a discharge of about 8,000, a total discharge of roughly 8,000 cubic meters, you should select the unit in cubic meters and not in liters. Because when you sum up these numbers, you quickly reach the overflow of the instrument, and you won't be able to display the correct data anymore. So change the unit to cubic meters, and you can calculate the total discharge for a much longer time than using liters in this case. And also, as we have seen above already, is take some considerations when you adjust the decimal points. So if you change the unit, for example, from liters per second to cubic meters per second, make sure that you use 2 or 3 decimal places instead of 0. Because when you use 0 or just 1, you lose a lot of information and a lot of accuracy. So when you change a unit, consider also adapting the decimal places of these units. Okay, these were the basic settings which are set in the Q commander, and I just want to point you to some advanced settings that you might consider using in your application as an option for additional outputs. The RQ system offers a limit monitoring. Here we can see the section in the setup, the dig out limit monitor. And with these settings here, you can specify a trigger when a certain measurement is reached. For example, if the discharge of a river reaches a certain number, in this case, the discharge is 15 cubic meters per second. If this discharge is exceeded, the digital output of the RQ system will be set high. That means to the flow velocity, to the supply voltage of the instrument. And as soon as the discharge falls below the 15 cubic meters again, the digital output will be set to 0 again. And you can set this trigger to discharge or a level measurement. You can also specify if you want to have the trigger if you have a limit overrun, or in the other direction when you go under a certain limit value. You can specify also a limit value, maximum or minimum. Okay, and then you also have the option to give out the data of the RQ instrument not only by RS-485 or SDI12, but also by an analog signal. And the RQ provides 4 analog outputs, one for the so-called auxiliary input. If you attach, for example, a temperature sensor to your RQ instrument, you can read out the temperature value from the analog output number 1. And the analog output number 2 is the water level, number 3 the flow velocity, and number 4 the discharge. So you can set the scales and measurement range with these analog settings here in the setup for the 20 mm outputs. Okay, so I've told you some information about the basic settings and some advanced options you may use in your application. And to sum up on my presentation here, I would like to show you a good tool that is provided by the IQ instrument to identify the quality of your measurements. And this is called the spectrum mode in the Q Commander software. So when you at the site, when you install the instrument, you can use this mode to optimize your measurement. And I will show you when to use it, how you apply it, and what you will see with the spectrum mode. So when you go out in the field, you have chosen a measurement site, and you're going to install your RQ instrument, and you want to make sure that you're getting good measurements. Then you can open the Q Commander, go to the measurement section here, and then look at the commands here, spectrum commands, and then say, for example, start spectrum mode, and then Q Commander software will take a little time to gain all the data that are required, and will finally display spectrum here in the measurement graph. Looks like this here. You see on the x-axis the velocity in meters per second, and on the y-axis the intensity of the signal you receive from the velocity sensor. So this, in a good measurement, it usually shows a peak like this, either in the positive direction, upwards, or in the negative direction, depending on which flow direction you have installed your instrument. The shape of the peak will give you the information about how good your flow velocity measurement is. So here, for example, is an example of a good flow velocity flow measurement, where the sensor is looking downstream, and we have one nice single peak, and the colored area underneath, that is actually the information used to calculate the flow velocity. But what you have to look at is my peak, is it a single peak, and is it shaped quite well? And additionally, in the spectrum mode, we do some regular measurements, and you can see the results up here that correspond with this spectrum here. In this example, flow velocity of 0.7 meters per second. That is the red line here in the spectrum. You get the final water discharge, and you get two numbers for a quality indication of your measurement. First is the SNR, the signal to noise ratio, and the opposite direction 0.8%. So these are two quality variables that you look at beside the spectrum here. Regarding the quality signal to noise ratio, in this example we have a value of 80, that is very good, and usually values above 60 are super values, so a good velocity measurement. 50 to 60 is still good, 40 to 50 is sort of okay, and 30 to 40, this is a value that you should probably improve to get a better reading of your velocity. If you read values below 30, then you definitely need to make some adaptations on the measurement in your installation site. Here another example of a good measurement. We see here a velocity of almost 1 meter per second, very high SNR, quality value of 75, and a very low opposite direction contact. And also the spectrum shows one single peak that is pretty smooth, so this is a good velocity measurement. On the other hand, bad example, what you can see here, we have a flow velocity of 0.4. You see that the quality is still very high, so you would say this is a good measurement. What you also see is the opposite direction is extremely high, so this is an indication that something might be wrong. And again, looking at the spectrum, we see that the spectrum looks very bad, it's very rough and a lot of noise. The other one, this tells us no, this is not a good measurement. This can have very different influences. It can be crosswind, it can be standing waves, it can be echoes from any obstacle or big surface, which might produce this very bad spectrum thing. And also another example of a problematic spectrum in this measurement, where we still have very good flow velocity and a very good signal to noise ratio, and also the opposite direction is quite good. But when we look at the spectrum, we see that we have two peaks in our spectrum. And you see here the red green line that corresponds to 0.7 meters per second is in between these two peaks. So this might be an indication that we have some reflection somewhere which produces a secondary velocity peak, which is difficult to interpret by the sensor. So if you see a spectrum with two or more peaks, then you definitely need to change something. You might have to move the sensor to a different place or consider any reflections or other issues that could lead to this spectrum. Again, just for a note, look at your flow velocities to discharge and the quality criteria, the SNR ratio, and the opposite direction, but also consider the spectrum, because the SNR and the opposite direction don't give the full picture of the quality of your velocity measurement. Also look at the spectrum. And you see here a good spectrum has a single peak in either direction, and a bad spectrum has a very noisy signal that has more. So I hope this information gives you enough information to set up your RQ station, and gives you some ideas what to consider and how to assess the quality of your measurements. And so thank you very much for listening, and please provide your questions if you have any right now. Thank you.
Thank you very much, Johannes. Very interesting presentation. Let's start with one of the first questions. How important is it to look at the spectrum when you go to a site and when you deploy a site?
Generally, it's a very good idea always to look at the spectrum to make sure that your that your velocity reading is correct. You might think your measurement site is good, your quality criteria are good, your velocities, your results seem reasonable, but you might have disregarded any reflections. And looking at the spectrum makes sure that you really have a good measurement.
Okay. The RQ has a couple of measurement triggers. Which one are the most used and which is the most convenient one in your opinion?
If you use, or very often, the RQ is used together with an MRL7 data logger, and then either the interval option or the trigger option by RS485 or SDI12 is the most simple one. If you use a third-party data logger, then most often the SDI12 or analog signal is used. But using a SUMR data logger, MRL data logger, is usually the easiest way to handle or to trigger the measurements and handle the data.
When you use a data logger and STI-12 communication, for example, to trigger measurement, who is controlling the interval of the measurement? Where do we set up the measurement interval?
Yeah, in this case, the data logger controls the measurement interval, and it sends out, it pushes a command to the RQ instrument, and as soon as the RQ receives this command, it takes a measurement and then automatically returns back the measurement values to the data logger.
When doing a site selection, when talking to a customer looking at a site, what would you say? What are the 2 to 3 most important things you have to keep in mind looking at a site?
Most important is that you have a good or a reasonably good flow of the river, that it's more or less straight, that it has a stable cross section, so that the cross section doesn't change very much along the river, and that you don't have any inflows or outflows that could change your flow, and also any obstacles within the river, like big rocks or stones or vegetation on the surface on the riverbed.
Okay. How important is the looking up or looking downstream of the sensor? Is there an advantage when the sensor is looking upstream or downstream?
Generally, no, except when there is rainfall. The rain produces some secondary waves on the water surface, and these waves produced by the rain will flow with the river downwards. So looking upstream might be a better option when there is rainfall. But otherwise, there is not much a difference.
Okay. Okay, in that case, that's basically all the questions I have here at the moment. Are there any other questions from the participants? Please raise your hands, ask your questions, write them in the chat. Let us know which questions we didn't answer, so we can answer them now. If that's all the questions, you're very welcome to still post an email to office@summer.at. Ask the questions about the trainings, ask the questions you're interested in. We answer them as soon as possible. Vishal raised a hand. Vishal Singh. Vishal, you can unmute yourself if you like and ask a question. Vishal, any questions? Oh, there's a question in the chat. Can you send me installation manual? Okay, yes, we can of course send all of you installation manual, or we can actually put it on the cloud where you can download also the recording of the webinar. We also upload manual if you like. Okay. Are there any other questions? There's another question coming. Okay. It seems there are no additional questions anymore. In case there are coming a few questions afterwards, during the afternoon or during the evening, please don't hesitate to contact us. Johannes and me will be answering the questions as soon as possible. Okay, in this case, thank you much for your attention. It was a pleasure for us. We keep you up to date about new webinars, about new sessions and learnings. And we are looking forward to see you in the future as well. Okay, thank you very much. Bye.
Thank you as well. Yeah. Bye bye.